Hello friends, in the previous videos we looked at two numerical integration methods. One is the trapezoidal rule, the other is the Simpsons 1/3 rule. In this video we're going to look at a new numerical integration method, which is Simpsons 3/8 rule. Our objectives are to numerically integrate a function using Simpsons 3/8 rule. Simpsons 3/8 rule, like the trapezoidal rule and the Simpsons 1/8 rule, falls under the closed form of the Newton-Cotes integration formulas, which are the most common numerical integration schemes used. Here we replace a complicated function or tabulated data using an approximating function that is easy to integrate. The general Newton-Cotes formula is given as I equals integral a to b f of x dx, which is approximated as integral a to b fn of x dx, where fn of x is the polynomial of the form a0 plus a1 times x plus a2 times x squared and so on, plus up to an minus 1 times x power n minus 1 plus an times x power n. Here n represents the order of the polynomial. If n equals 1, as shown in figure 1, we get the first order polynomial, which is a straight line. If n equals 2, as shown in figure 2, we get the second order polynomial, which is a parabola. If n equals 3, we get a third order polynomial, and so on. For Simpsons 3/8 rule, we have to use n equals 3, which is a third order polynomial. Simpsons 3/8 rule is obtained by fitting a third degree polynomial to 4 equally spaced discrete points. So I equals integral a to b f of x dx, which is equal to integral a to b f3 of x dx approximately. So f3 of x is represented by a third degree or third order Lagrange polynomial. For a single interval of 3 increments, we have I equals 3/8 times h times f0 plus 3f1 plus 3f2 plus f3. This is the formula we can arrive at when we substitute a third order Lagrange polynomial into that integral a to b f3 of x dx. Simpsons 3/8 rule for equally spaced points is obtained by applying previous equation over the entire range of integration. Note that the total number of increments must be multiples of 3. In the case of Simpsons 1/3 rule, the total number of increments or the total number of segments must be even. So we have I equals 3/8 times h times f0 plus 3f1 plus 3 times f2 plus 2 times f3 plus 3 times f4 and so on, plus 3 times fn minus 1 plus fn, which is the general equation or the general formula for the Simpsons 3/8 rule that has n segments. The global error is of the order of h power 4, where h is the interval size. Now we want to do an example. We will use Simpsons 3/8 rule to integrate this function f of x given here, where the limits of integration are a equals 0 and b equals 0.8. The value obtained analytically is 1.640533. We will now evaluate the integral using Simpsons 3/8 rule numerically, and then we'll compare the results. We'll also vary the number of segments n. So this is the Matlab code for Simpsons 3/8 rule. The function f of x is given here, and the general formula for the Simpsons 3/8 rule is given as I equals 3/8 times h times f naught and so on. The limits a equals 0 and b equals 0.8. We'll initially consider the number of points n equals 7. So it has to be, the number of segments has to be the multiples of 3. So the number of points has to be multiples of 3 plus 1. And the x values can be obtained here. The function f at these x values can be obtained here. And we use this Simpsons 3/8 rule formula to figure out the integral value. When we run this, we get I equals 1.632948, which is close to the exact value of 1.640, etc. So we will now change the number of points from 7 to say 28, which is multiples of 3 plus 1, and rerun this case. And in this case we obtain a value of 1.6405, which is close. When we go and change the value of n again to say 61 and rerun this case, we get the value of 1.640533, which is pretty close to the exact value. To summarize, in this video we presented Simpsons 3/8 rule to numerically integrate a function f of x. The error is of the order of h per 4, and this is the same as this when we use Simpsons 1/3 rule, which also has the error of the order of h per 4. So why do we use Simpsons 3/8 rule when we can use Simpsons 1/3 rule? Simpsons 1/3 rule, and if you have to use, the number of segments need to be even. So if the number of segments are odd, we can use Simpsons 3/8 rule. And we have to note that the number of segments need to be multiples of 3. In some cases, a combination of these two methods can be utilized. The 3 increments can be evaluated by the 3/8 rule, and the remaining even number of increments can be evaluated by 1/3 rule. In the next video, we can look at other methods such as Gauss quadrature methods. Thanks for watching the video. If you have any questions, please post it. I will be uploading the code into a website. I'll give you the location in the YouTube. Thank you.